Hi, today we're going to take a look at one particular assembler for Commodore 64 and see what makes it so special and so easy to use in the same time. In addition, we will discover some hidden options that will allow us to merge assembly and basic code together in the same source file, and that will be interesting to see. Now, I must admit that this assembler has become one of my favorites for Commodore 64, and you will see why very shortly. But now, let's take a look at Mikro Assembler. So here it is, we are in Mikro Assembler. Now, if you already use this assembler, well, you know what's happening here. If not, well, try to figure it out. In the meantime, let me tell you a little bit more about this assembler. So, Mikro Assembler was written by Mr. Andrew Trott, initially for the VIC-20 machine back in 1981, and it was published by Supersoft company from England in 1982. Now, the version for Commodore 64 was released just a year later, also by the same company, and it was sold as a cartridge, and this was very handy because it uses a minimal amount of memory from Commodore 64, leaving the majority of memory free for us to use for our code. So back then, if you want to develop in assembly software for Commodore 64 on Commodore 64, this was very neat solution. So these images and shots that you're looking right now are kindly sent to me by my good friend Steve from 8-bit Retro ReFix channel. Well, it turns out that this cartridge is really rare, but I will put the links into the description of this video for the CRT images and other resources for this assembler that I found, so you can try it out yourself. So what is so special about it? Well, it is its user interface. And where is it, you may ask? Well, you're looking at it, and this is what makes this assembler really user-friendly, because I'm sure that you already know how to use this user interface, because it's Commodore 64 basic user interface, the one that we use all the time. So it uses Commodore 64 basic editor to write, edit, save and delete assembly code. And how that looks like? Well, the same as you would write the basic code, now you can write assembly code. Let me show you. Let's write simple program in assembly. Of course, we are using this basic interface and we need to use the line numbers, so it's a little bit weird to see that, but here we go. So line number 10, we need to define where our program is going to be stored into memory, and we do this very simply, like in any other assembler. And then next line, let's put label, and let's increment the border color. Yeah, that's like very short program, so we are just incrementing the border color, and then we have simple jump back to our loop label. So here we go, this is our assembly code, and let's list it. Okay, and the way that we assemble it is we simply write assemble. That's about it. So this Mikro Assembler cartridge expands basic commands, add few of their own, and this is one of them. So if I hit assemble, we will see that our code is now compiled, and we have some useful information on the screen. We have our start address and end address, so we are beginning at 1000 hex like we defined in our little program. So all we need to do now is simply call the sys command with pointing to that address. If you don't know the decimal representation of that hex value, there is a very handy command that comes with Mikro Assembler. It's called number, and if you enter some value either in hex, decimal or octal or binary format, it will display all possible combinations, and this is very handy. So now I know that I need to call sys 4096, and if I press return, this is what we have. So our little program is working and changing border color constantly, and we can end it, of course, like you would end any other program. Our source file is still here, and you can save it as you would save the basic file. You can save this on a tape, on a disk, whatever. So let's try to write something more interesting. So let's start with the new, and again we are going to begin our program at 1000 hex, and then we are going to define again our label. And what we are going to do now is going to use exclusive OR of address, so D012, and this is the memory location where the raster line number is written. So using this value, we are applying exclusive OR, and we are storing that into our accumulator. And the next line, we are going to end our accumulator with a value of hex 01 or 1. That means that after this instruction is executed, in our accumulator we can have either 0 or 1. That's it. So only two possible combinations. And the next, we are going to add to our accumulator. So we are going to add a value of CD, and this CD is the value of one of the passkey characters. So after this, we are going into our accumulator, we are going to have either value CD or CE, and you can check those passkey characters and see what they are. And now what we are going to do is we are going to call one of the kernel routines to print out character on the screen, and it's ffd2. So whatever value is in accumulator is going to be printed on the screen. And into line 60, we are going to just jump back to our loop label. That's it. That's our program. So yeah, let's try to assemble this one, and it's done. So again, we are beginning at address 1000 hex, but now we know that this is 4096, and here we go. And as you can see, this little assembly program is our 10 print maze. And if I slow this down, you can take a look a little bit better. Yeah, and we can stop it. So writing this little assembly pieces of assembly code is just fine. But let's say that you want to develop the whole game or something more complex using this Mikro Assembler. Of course, because the Commodore 64 has only that much memory, we are limited to that. And whoever works in assembly knows that those files, the amount of code can be very, very large. So how do you fit all of it in memory of Commodore 64? Well, you can't, obviously. You can load that much that you can. So what Mikro Assembler has built in, except for these assembly instructions, there is some additional pseudo opcodes that you can use inside your code, and one of them is very, very useful. It's called link, and it's used to link another file into your main file. Let's say that I between these two lines 50 60, let's say that I want we'll add another line of code, and we are going to link another file. We are going to link another assembly code, and we have to specify the file name of that source. So other file, let's call it the other file, and we need to specify where device where this file is going to be loaded from. So this is how it's done. When we compile this code, when the assembler hits the line 55, it's going to try to load different file, that file that we specified from the device number 8. And once it's finished assembling that file, compiling that file, it will search for the end pseudo opcode, and here in that other file we have to specify where do we want to return to. So let's say our main file, and where is that main file stored? Of course we have to specify the device number again. So this is the way how you actually can link different files. So we are including the source from one file to another file. This is the way how you can actually build more complex applications or games for Commodore 64 using the Mikro Assembler, and divide that into a couple of files, save it on your disk or disks if you have multiple disk drives. And there are a couple more commands that you can use that are part of the Mikro Assembler, and so let me show you that. One that is after we assemble our code, we can, let me just delete this line number 55 and 70, we don't need that. Yeah, so once you assemble your code, you can use the command that's called format, and it will display your assembly code in a little bit more familiar format, so it doesn't look like a basic code, it does look like real assembly code. There is also very handy command that's called table, and that's just a list of the labels that you use in your code, and this is very handy when you have a large number of labels and when your project starts to grow and there is lots of jumps. Also there is a find command, so you can try to search. Let's try to find FFD2, and it will find and display the line number where it actually find that value. And of course, like any other assembler, you still need to do some monitoring and debugging and other stuff, so it has built-in a monitor as well. It's called TIM. So if you call TIM, like any other monitor, it's very easy to use. So here you have a representation of all values of all registers and stuff, like a little bit of summary, and you can and specifying the address from 1002, so it doesn't understand that, so you have to specify from to, so from 1000 to 1010, and this is what we have. So this is our little program here. So, and this is not just displayed on the screen, this is these are the live values, so you can change any value here. So if I change this, so where is that, FF00, if I change this value to 60, it will be stored into memory. If we try to show it again, you see that it's now stored as 60, and store it back. So you can change the values directly here. Also you can disassemble. So let's disassemble from 1000 to 1010. So as you can see, this is our little program. Yeah, just normal monitor, and you exit with the X. This is our program. So, well, is it possible to combine, because this is obviously basic environment, so is it possible to combine basic commands and assembly commands or instructions in the same file and try to do something that is that could be interesting? I tried that, and yes, it is possible. So let me show you what you actually can do with it. And of course, to do this, you have to have a Mikro Assembler cartridge in your Commodore 64, obviously, because otherwise those assembly instructions won't be recognized. So this assemble command, so far we have been using it like this, so direct, just type in the assemble and you press return. But this is now a basic command. We can use it as a part of our source code. Why not? So we can add assemble at line number 5. Sorry, this is how this looks like now. And if I try to run it, you will see that the assembler has been called, compiler has been called by this command, but he is trying to assemble the whole source code, and of course the first line is this line number 5, so it's assembled, so he doesn't understand that. So what can we do to avoid this? Well, if you take a look at the documentation for this cartridge for Commodore 64, there is nowhere that is mentioned that this assemble command has or can have additional parameter, and this additional parameter is actually used to tell the compiler from which position, which line number is going to begin our assembly code. So where is going to start compiling from. So what can we do here is just say assemble and then assemble it from line number 10 and going forward. So if I run this little code now you can see that our little program has been compiled. So yeah, this is nice. So let's try to continue a little bit more here. So now we are already combining our assembly program with basic code. So let's say that after I compile this assembly code, we cannot just say, okay, let's call the sys4096. If I run this, it will give me the opcode error in line number 70. So first of all, we have to now tell the assembler where is the end of our assembly code. So what we are going to do is we are going to add line number 65 and we will define it as end. And this also means that this is the end of our assembly code. So this is how this looks like now. So our assembly code actually starts on the line 10 and ends on line 65. So let's try to run now. And as you can see, now it's compiled perfectly, except we have a little problem. The problem here is that line number 70 in our source code hasn't been executed. Yeah, when this compiler is done with compiling, it simply just returns back to basic, so it stopped executing, and this command, sys command on line number 70, is never executed. But we can change that as well. It's a bit more complicated, but we can try to do something with it. But for now, let's see what can we do as it is. What can we do with this, and can we make something that is actually useful, combining basic and assembly code. So let's see, let's define line number 1 and let's put input here. So this is our temp print maze, and let's call it, if we press 1, then we are going to compile, and if we press 2, we are going to run this, and we are going to define input to the variable d, and on line number 2 we are going to set, say, on the goto. So if our d variable is going to be 1, we are going to jump to one location. If it's 2, that we are going to jump on another location. So on the first, if we press 1, we want to compile it, so we are going to jump to line number 5. And if we don't want to compile it, we want to run it, then we can jump to line number 70, where is our sys command. So let's try to print this, see how that looks like. So yeah, I could remove this just for the readability, yeah, to make it look nicer. So waiting for the input for the d variable, and in case that variable d is 1, we are going to compile the code. That means that we are going to call assemble command with the parameter 10. So that means that it's going to compile from line number 10 up to the 65, where our assembly code ends. And in case that we are choose second option, so number 2, we are going to jump to line number 70 and execute this sys command. So okay, let's try to run this code, and now we have 2 options. So let's choose number 1, and now we compile our little program. And if we run it again and choose number 2, then we are running the program that we just compiled. Yeah, so here it is. Yeah, and you can save this as a normal basic file. Yeah, is it very useful? I don't know, maybe back then it could be useful. So, but can we assemble and automatically run our program without typing in and restarting the program and do all this nonsense? So can we just run the assemble command? Once it's done, the program starts running. Yes, we can do that. There is little hack. It's not a hack, it's just the way how the system behaves. So what we have to do is, before we call the assembly program, assembly command, we have to fill in the keyboard buffer with certain commands. And once the assembly, once the microcompiler is done, so the assembly command is completed, once it returns back to basic, it will restore and it will check vectors and everything, and one of those things that is going to be checked is keyboard buffer. And if there is something in it, and it's going to be something ready and prepared, it's going to be executed. So yeah, let me show you how to do that. What we are going to do, we don't need line number 2 anymore, and we are going to change to line number 1 completely. So what we are going to do, before we call the assemble command, we're going to fill in the keyboard buffer, and the values that we are going to store in that keyboard buffer, we are going to store them as data values later in the code. So for now, I'm just going to write a for loop that's going to read all the data information and just fill in the keyboard buffer. So let's go for I equals 631. So 631 is decimal representation of memory address where the keyboard buffer starts, and we are going to 631 plus 7. We're going to read variable a, and we are going to poke at variable I a, and we'll do next. And after the next, we are going to poke, we have to poke another register in memory, and we need to poke at one 98, and we have to tell the number of characters in the keyboard buffer, and this is it's going to be 8. And now I have to add data which are we going to store in our keyboard buffer. So let's and we will not need this line number 70, so I'm going to use the line number 70 to store our data. 83, 89, 83, 52, 48, 57, 54 and 13. Now these values are not magical values, there is no hacking here. These are just decimal representation of this same of the characters which are actually saying sys 4096. So this is letter S, Y, S, and so on and so on. And the last character is of course the value that represents our return key. That's basically it. So actually we are going to use the keyboard buffer, fill it in with exactly this sys 4096, and additional character is going to be returned. So once that gets executed, it will print this sys 4096 on the screen, and the return key will be executed. This here is just RAM sys 4096 and addition with return key. So yeah, this is just it. Let me clear the screen, and yeah, so this is our code. So let's try to run it, and here we go. Ta-da! Is this very useful? I don't know, maybe you can write some sort of setup files or something like that, some kind of configuration for the assembly, which part of the assembly code is going to be assembled and executed. But unfortunately you cannot just, the assembly code has to be in continuous. So once we start at line number 10 and we say that okay, this is the beginning of our assembly code, yeah, it has to be all the way up to the end. You cannot interrupt it and jump back to basic and then go back to assembly again. But yeah, still it's very weird to see all of this in the same source. I will try to slow it down really so that you can see what's happening. Run it, and now you can see here that we have our sys 4096 displayed on the screen. Yeah, so that's the result of our keyboard buffer. Yeah. So this is all that I have for you today. I hope that you enjoyed this little Mikro Assembler experience. I certainly did. I think it's very cool to write assembly code inside the Commodore 64 default environment, so that's something, yeah, very beautiful. Like I mentioned before, I'll put every information that I found about this assembler into the description of this video for you to check out. There is CRT files there. You can run that in your Vice emulator or any other emulator and try it yourself. So yeah, that's all. Until next time, goodbye.